All right, guys, we're here talking today about increasing and decreasing intervals for a function. And what we're going to do is we're going to learn the connection between the sign of a derivative and the intervals where a function is increasing or decreasing. And we've talked about this quite a bit already, but now we're going to start using some sign charts to determine where f of x is increasing or decreasing. So some important ideas concerning increasing and decreasing functions. When a function is increasing, bigger inputs means bigger outputs. Well, what do you mean by that? It means if f is increasing, when some x value is greater than the other x value, that implies that the y value for that x is greater than the y value for the other x. I know that sounds a little weird, but think of it like this. If I have an x value of, let's see, I'm gonna take two x values here, and we're gonna say that I have these 2 points, and I'm just going to make this nice and easy. 1, 2 and 4, 5. All right. So this is my x1, y1. This is my x2, y2. And so if you look at the notation here, it says f is increasing whenever x2 is greater than x1. Okay, so I definitely have that. I have 4 is definitely greater than 1. And that implies that f of x2 is greater than f of x1. And you can see here's my f of x2, that's 5. And that's definitely greater than, that's definitely greater than my f of x1, which is 2. Okay, so you can think of these as y1s and x1s, or y1s and y2s, or you can think of them as f of x1s and f of x2s. Okay, so that's basically how the notation is working there. And you can see just by looking at these coordinates, 1, 2 is definitely below 4, 5 if you were thinking about an increasing function. So when a function is decreasing, the opposite happens. Okay, bigger inputs mean smaller outputs. F is decreasing when x2 is greater than x1. Implies that f of x2 is less than f of x1. Okay. Let's see. When a derivative is positive, a function is increasing. When a derivative is negative, a function is decreasing. And again, we've talked a lot about that in the past. All right. Symbolically, it says the derivative of f is given by f prime of x equals 3x squared minus 12x. On what intervals is f of x increasing? So the first thing we want to do is we want to find out where the zeros of the function are. Okay, so we want to look for the zeros. So when we look for zeros of a function, we basically want to take the derivative and set the derivative equal to 0. Because if the derivative is 0, then the function is neither increasing or decreasing. Okay, so when my derivative is 0, I'm basically, at a max. In this case, the picture I've drawn, I'm at a max, or maybe I'm at a min where there is no slope. The other thing we want to look for is my function undefined? And we're going to call these critical values or critical numbers. Okay, so when we are looking for intervals of increasing and decreasing, we are going to look for critical numbers. And those critical numbers include 2 things. They include where the derivative, f prime, is undefined. And so if I look at this function, this is a polynomial function. Polynomial functions are not undefined. So this doesn't apply here, but we're always going to be thinking about that. The other thing I want to look for is where is my derivative equal to 0, f prime equal to 0, because if the derivative is equal to 0, then I'm neither increasing or decreasing. In this case, we can set the derivative equal to 0, so we're going to start off with that, and we're going to do 3x squared minus 12x equal to 0. And I'm going to solve this equation, and I'm going to go ahead and factor out a 3x. That's going to leave me with x minus 4. If you set both of these factors equal to 0, you're going to get x equals 0 for one solution, and for the second solution, you would get x equals 4. Those are my critical numbers in this case. So what I want to do with those is I want to set them up on a number line. similar to what we did in Unit 4 with our position, velocity, and acceleration functions. So I'm going to have two numbers on my number line here. We also call this a sign chart. And what we want to do is we want to find out what f prime of x is doing in between those numbers and outside of those numbers as well. So in the previous chapter, what we did is we said, okay, we're going to plug in a number that's less than 0. So maybe we plugged in x equals -1. And so I would go back to my derivative function right here, and I would plug in -1. All right, all I care about is this derivative positive or negative when I plug in -1. So you can see if I plug in -1 for x next to 3, I would get 3 times -1, and then I would get -1 minus 4, and that's going to be -3 times -5, which is positive 15. Now I don't care that it's 15, I just care that it's positive. So I'm going to say that this first interval, f prime, is positive. Now, what I'm really looking at and wanting to know is what's happening with f of x. Well, if f prime is positive, then f of x is increasing. And I would do the same thing in each one of the other intervals. Maybe I go to the second interval and I pick x equals 1. And so again, I would go back to my derivative function. I would plug in 1 for x right here. And I would have 3 times 1, which is positive 3. So that's positive. I would have 1 take away 4, which is -3. That's going to be negative. And positive times negative is going to make this interval negative. Oops. Not sure what happened to that there. Negative. And then I would do the same thing in the last interval. So maybe in the last interval I'd pick 5. X equals 5. And I plug it in again to my derivative. 3 times 5 is 15. That's positive. 5 minus 4 is 1. That's positive. So I have positive times positive, which makes this last interval positive. And again, the whole reason we're doing this is so we can tell what's happening with f. So in the second interval from 0 to 4, since f prime is negative, that means f is decreasing. And then we go back to f prime being positive from 4 to infinity, so we would say that f is increasing. All right. Now, we're not done yet. It said on what intervals is f increasing. So now we need to write out our solution here. So I would say that f is increasing on, and I'm going to list the intervals here, -infinity to 0. Okay, this is a little bit different from position and velocity because position and velocity starts at 0 because we're talking about time. There's no restriction on this one, so I'm going to go all the way to negative and positive infinity. So we have, let's see, -infinity to 0 and 4 to infinity. Because, and the reason we know that is because f prime is positive. Okay, so there's the first one. The second one says the function f is differentiable for all real numbers, and its derivative has exactly 2 zeros. Selected values of f prime, the derivative of f, are shown in the table. What are all the intervals of x where f is increasing? So it does tell us a couple of things here. It says the derivative has exactly 2 zeros, and you can see in the table I've got a 0 here at x equals 0. I have another 0 at x equals 4. So there's no other zeros. The derivative is never equal to 0. And they want to know, where is f increasing? Well, just like our last one, I want to look at, if f is increasing, that means my derivative is positive. So if you look at this first section in the table, those are all positive. If you look at the last section in the table, those are positive. And because they told us the derivative has exactly 2 zeros, we can assume that everything else in those green intervals is positive as well. So I would say pretty much the same thing I did as last time. F is increasing. Now this time, let's see here, the function f, I'm not sure. I should probably go all the way to negative and positive infinity again because they didn't restrict it to just the table. So f is increasing on, let's see, we'll say negative infinity all the way up to 0, and 4 to infinity, because f prime is positive, or we can also say greater than 0. Okay? So when we make these justifications, what we want to keep in mind is, in order to justify increasing or decreasing behavior of a function, we say that f of x is increasing on an interval because f prime is greater than 0 or positive. F of x is decreasing on an interval because f prime is less than 0 or negative. When you do these, making these connections verbally is necessary. Okay, so in example 1, we just did the sign chart, but we also explained the meaning of that sign chart and what is happening. So you have to be able to explain. A sign chart alone is not enough. Okay? All right. So processes for finding where a function is increasing or decreasing. So number 1, we want to solve for f prime greater than 0 or f prime less than 0. How do we do that? Well, we just did it in the other examples. We find the zeros of f prime. We put them on a number line. We sample a value in each interval to determine whether f prime is positive or negative. We make our conclusion, and we justify our answer by making a statement connecting the intervals to the sign of the derivative. I would encourage you, if example number 1 and 2 made sense, I would encourage you to turn off the video and try this one on your own and see what you get. All right, so the first thing I want to do is I want to look for, I'm gonna find f prime of x. Okay, so I'm going to find the derivative f prime of x. All right, so if we do that, we would end up with x squared minus 2x minus 15. And then we always want to be thinking about what are those critical numbers. Critical numbers here. So remember, critical numbers are, where is f prime, the derivative, f, there we go, f prime, where's that undefined? So I'm going to just use UND for undefined. And again, this is a polynomial function, so there's no places where this is undefined. So in this case, undefined does not apply. But we always want to keep that in mind because we're going to see some of those later. The other thing we want to look at is, where is f prime equal to 0? Okay, so that's the first place I'm going to start. I'm going to set my derivative equal to 0, x squared minus 2x minus 15. And I'm going to solve this by factoring it, so we can factor that. That's going to be x, let's see, what do we got here? Minus 5 and x plus 3. And so we're going to end up with 2 zeros here again. We're going to end up with negative 3 and positive 5 as our zeros. That's where the derivative is equal to 0, so that's where we are neither increasing or decreasing. Okay, so we have negative 3. We're going to set up our number line. We have positive 5 here. What we're doing is we're looking at what is happening with f prime of x so that we can say what's happening with f of x. All right, so we're going to plug in some numbers. So in this first interval here, from negative infinity to negative 3, I'm just going to choose negative 4 because it's just to the side here. If you plug in negative 4 to the first factor, that's going to be negative. If you plug in negative 4 to the second factor, that's also going to be negative, which means that this first interval is positive, which tells me f is increasing. We go to the next interval, negative 3 to 5. Well, 0's in there, and 0's always an easy one. So if you plug in 0 to the first factor, that's negative 5. If you plug in 0 to the second factor, that's 3. So that's negative times positive, which is going to make this interval negative, which tells me that f is decreasing. And finally, I'm going to go back to the last one, plug in 6, and both of these factors become positive. So we have a positive and an increasing. All right, we still have to write our justification here. So we can say that we'll start with increasing. F is increasing on, I'm going to list the two intervals, negative infinity to negative 3 and 5 to infinity because f prime is greater than 0, or positive, however you want to say it. I go to the next interval. I'm looking now for decreasing. F is decreasing on -3 to -5, just in the middle portion there, because f prime is less than 0. Okay? So hopefully that's what you came up with when you tried it on your own. Let's take a look at a couple of graphs and see what's happening here. So we've got two graphs here. They're exactly the same, but the first one says determine the intervals where f prime is positive or negative based on the graph of f. Okay? So f prime positive, that means your derivative is positive, which means f itself has to be increasing. So if you look at this portion of the graph right there, f is increasing there, but it's decreasing here and here. So I'm going to start with the increasing part. I would say that f prime is positive. You could also say greater than 0. F prime is positive on the interval from -2 to 2 because f is increasing. So that justification that we were using before in the previous example, when we were talking about f increasing because f prime was positive, you can use that the other way around too. So in this case, we're saying that f prime is positive because f is increasing. So the other one says, where is it f prime positive or negative? So the negative intervals are the green ones. F prime is negative or less than 0 on, so we're going to go -infinity to -2. And what's the second one? 2 to infinity because f is decreasing. All right? But then you look at the next graph on the right, it's the same exact graph, but now they're saying, look, determine the intervals where f is increasing and decreasing based on the graph of f prime. So what they've done is they've taken the graph and they've switched it from f to f prime. So now I'm looking at f prime. So take a look at this interval right here and this interval right there. That's the graph of f prime, so f prime is positive right there. So I can say that f is increasing on -infinity to -3 and +1 to +3 because f prime is greater than 0 or positive. And likewise, I can do the same thing for f prime being negative. So I've got negative here and negative here. So I would say that f is decreasing on, what do we got here? -3 to 1 and 3 to infinity. 3 to infinity because f prime is less than 0 or negative. All right? And that is all for today.